Hello and welcome to this video. This is the third and final video in the series about LAL developers we need to do better. In this video we're going to talk about testing. So let's get started. First off, remember there's a link in the description below to the blog post based on this topic. Now I know when a lot of you hear the word software testing, you're going to say, oh no, not test. But we cannot get around the fact that we need to have tests to make better solutions. So we need to somehow to make testing sound more sexy. So what I did was I asked ChatGPT, how do we make software testing sound sexy? And this is how it answered. Software testing is an essential part of software development that helps ensure the quality and reliability of software applications. Here are a few suggestions to make it sound sexier. Emphasize the impact it has on delivering top-notch user-friendly software to the market. Highlight the role it plays in identifying and fixing bugs before they become bigger problems for users. Call it a quality assurance process that helps that software meets the highest standards. Emphasize the importance of testing in preventing potential security threats and protecting user data. Emphasize the creative and problem-solving skills required in software testing, making it an exciting and challenging career. By emphasizing the positive outcomes and important roles the software testing plays, it can become a more attractive and compelling field. Now, I don't know about you, it doesn't really make it sound that sexy. However, the fact is that, like it states, writing tests can be complicated. It can be a challenge, and that should actually excite many of you, because many of us actually like a challenge. That's why we are software developers. But besides that, it's also important to note why testing is actually so important. And to nail this point, I'm just going to take two cases where the lack of software testing had very bad consequences. Ariane 5 was a rocket with a value of $370 million. Everything worked fine, it launched. However, a software error in the Ariane 5, the rocket ended up self-destructing. Now the error was actually quite simple. The problem was that you had a float64 variable, which was then copied into an integer 16-bit variable, which caused an overflow. And this simple error told the rocket to self-destruct. The Theric 25 was a machine used to treat cancer patients with radiation treatment. However, a software bug in this machine caused it to give some patients too much radiation, causing 3 deaths. Now the problem here was not only a software bug. The problem was actually that the software in itself had so many bad error messages. Malfunction, and then it had a number from 1 to 100. No one knew what these malfunction code errors actually did. So what that meant was that in the beginning people were kind of scared because they got a malfunction, and then what should I do? But since you kept on getting them, people just got used to pressing P, which meant proceed. And in most cases everything went fine. However, there was one malfunction error, the malfunction error 54. This error was actually quite dangerous. And this was the error that caused the patients to get too much radiation. Now this software actually did have some kind of error handling. And it had inside the code a way of checking error codes. And if these error codes were not 0, then you could not run the machine, which was great. However, the variable that was used to store these error codes was a 56-bit integer. So once we got above a certain value, everything was just nullified and it would turn back to 0, which meant that even there was errors, it just continued, and then it treated the patient with the wrong dosage. Now you might be thinking, okay, but those examples are of old technologies. We don't have those kind of problems today. Well, we do. I mean, just look at the Tesla autopilot. How many times have we not heard the stories of it either crashing into other cars or just crashing into the wall or stuff like that? Software has errors and we need to test these errors. Now I know most of us are not working on programs or software where we actually cause people's deaths or anything like that when we do software errors. However, it's not unheard of that we have made some kind of change to the code. This might cause the customer not being able to ship their order, which results in that all their customers who has ordered something on the web shop are not getting their orders. Now, of course, this might not sound like a big problem, but try to think that if you order something from a web shop and they don't ship it, and you have to wait like a week for them to ship it, are you going to order from that web shop again? Probably not. So therefore, actually your software bugs can also have fatal consequences for someone else's business. Now again, I know people are not going to die from this, but it's still something that is actually affecting someone else's business. Now, software development is very complicated, and there's no way to make code that is 100% bug free. There is no silver bullet to solve the problem of software bugs. However, there are tools and workflows that we implement to make the amount of bugs smaller. Let's look at some of these. Now, when we talk about software testing, a lot of people are going to automatically think about unit testing. And while unit testing is a great thing and something we should implement, there's so much more in software testing. Software testing actually starts way before any line of code has been written. It already starts in the planning phase. And a good rule of thumb is that the earlier you catch a bug, the easier it is to fix. So if you catch something in the planning phase, it's a smaller bug than if you catch it in the writing task phase, or if you catch it in the development phase, or the testing phase, and so on. The longer down the phases you get, the larger the bug is, the more problematic it is to solve. So how do we catch these bugs as early as possible? In the planning phase, we have the requirement gathering. The requirements gathering is where the product owner, the developers, and the business consultant should actually look through everything to make sure that we have looked at all the possible risks that we are facing. We should look at potential design flaws, consistencies that could cause bugs later in the development phase. We should also look at the threat modeling. This is where we will look at if there's any kind of security problems that we might cause by doing this kind of code. You know, sometimes we have these kind of development things where we turn off some error messages or we turn off something. We have to make sure that if we do this, what consequences will it have? Because, you know, like the Theric 25, error codes are there for a reason. You shouldn't just ignore them. A great tool to assess this is using the SWOT model, where we have strengths, weaknesses, opportunities, and threats. And then we need to do use case analysis. This is where we actually go through the use case from the user's perspective and look at just exactly what this user is doing, and if it's actually needed for us to change something in the code, or we can just change their workflow. And if we do change something in the code, what will that change for someone else? Because we have to make sure that what we are doing is not breaking someone else's workflow. The next phase is actually writing the user story itself. Here it's important to write it from the user perspective. So you write what the user wants to achieve and how they're going to achieve it. So you have to have the end goal in mind. This will give us a common language to talk about some kind of problem and thereby also solution. This means that both the developers, business consultants, and the end customers all know what exactly we want this new feature to do. So we all have a common language and a common understanding of the solution and the problem. Now, an example of user story could be, as a sales manager, I want to be able to add a freight line to a posted document in Business Central so that I can accurately reflect the cost of a shipping for each sale. So that's a pretty simple user story. But besides that, we also need some acceptance criteria. By writing these acceptance criteria, we also already know how to write the test cases. And by writing test cases, we also know how to write unit tests. And agreeing upon these acceptance criteria with the customer already in the design phase makes it much easier going forward to make sure that you actually live up to what is expected. So some acceptance criteria to this could be the ability to add a freight line to the posted sales document is added to Business Central. The user can enter the amount of freight charge on a sales order or invoice. The freight charge is displayed on the posted document along with the subtotal, tax, and total amounts. The freight charge is included in calculations of total amount of the posted document. The freight charge is recorded in the general ledger and is included in the financial posting. The user has the ability to edit or remove the freight charge if necessary. The changes made to the sales document do not affect other parts of the system, such as an inventory management or customer billing. So, by having all of this ready up front, we have actually made sure that everything has been looked at as much as possible from all perspectives before we write a single line of code. And at this stage, it's much easier to change something. So it's easier to change a word on a page than it is to start trying to change code that is already doing something. Next up is the development phase. This is where we're going to start writing our automated tests. And the reason why we include automated tests is to make sure that everything is written in the same way and it's going to work no matter what else we're going to do. It's a great way to make sure that our code can be refactored. Automated tests can take many forms, including unit tests, functional tests, and integration tests. But the common goal for automated tests is to reduce the time spent on manual testing. Some of the benefits on automated tests are to improve reliability, because it should be easy and fast to run these automated tests every time we do a build of our solution. So instead of having to manually test everything every time we want to make a new release, it should be easy to run these automated tests. Also in the same scope, it should give us a faster feedback. By giving us a faster feedback, it's also easier for us to change anything faster and make sure that nothing is going into production that shouldn't be there. It will improve our code quality. Now, by improving the code quality, I mean that once you start designing your software to be able to be tested, you're already there deciding how to structure your code by bringing everything down into easy testable units. And it's going to give us better coverage of our test, because even though manual testing is something we should always do, the unit test can run a lot of different scenarios in a much shorter period of time, giving us the ability to test something that we might not actually find in a manual testing process. A good way to structure your tests and also to talk about tests, even with the user itself, is using the given when then principle. The given is where you decide on what should already be the preconditions before everything happens. It could be, for example, you need to have a valid sales order. You need to have a sales order with a sales number and a customer, for example. Then you have the when, and that will be when you actually do something. That's when you are posting this sales order. Then it's what happens when this is being posted. So that's the post condition. This is where it's actually going to do something. This is where it's going to create the freight line in our above example. But by breaking it down to these three symbols, it's easier also to write some kind of code to test this. Because then you know what are the preconditions, what do I need to execute, and what is the post condition, what is the result that I need before this has been accepted. Now, as I also talked about earlier, by start implementing automated tests, we also have to start thinking about how to structure our code in a way that makes it testable. And that's going to be one of the biggest problems that many of us face, because that's not the way that we have been writing our code. But some of the principles that we need to adapt to make our code more testable is the single responsibility principle, for example. Like I also talked about in the first video in this series, where we, instead of having functions that do a lot of different things, we have one function that does one thing, making it easier to test that one outcome. We also have to start using dependency injection. It's kind of the same thing, that where it's better for us to call another function to give a result to our given function than having one function that does many things. Then we need to adapt the concept of code refactoring. Because by refactoring our code, we're going to remove a lot of the complexity of our functions, making it easier to test. Another thing is to use test-driven development. This is where you actually write the test before you write the code. A good thing about this is that you already think about the outcome before you actually start writing the code. Now, this is something that's very difficult for many to implement or adapt, because the idea of writing a test before actually writing something that it can test might seem counterproductive, because the test itself, many people don't find that actually is that important. But you have to start thinking about that the test is actually just as important as the code itself. Then also we have to keep it simple, because as we also talked about before, as the more simple your code is, the easier it is to test. And then you should avoid global variables or global states, because it's very difficult to test global variables or global states. So keep everything local, keep everything isolated, because by making things isolated, it's easier to write a test to test that very specific scenario of that function. Now, I'm not going to write any unit test in this video. We might do a video series later where we're going to go a little bit more into depth about writing unit tests. But I would really recommend you reading the book by Luke. There's a link in the description below where he goes through how to write unit tests for AL. It's a must read for any AL developer. Now, even with all of these automated tests, which are performed in the development phase, we still have the manual testing phase. Automated tests are never going to replace manual testing, because manual testing is going to test something that the unit tests or the integration tests cannot test. Manual testing is going to be from the user perspective. It's going to find things in the user interface, it's going to look at usability and stuff that we're not going to look at from the code's perspective. To perform manual testing, I suggest that you adapt some of the test platforms out there. Now, Azure DevOps actually has a test plan included with test cases inside its program, which I would suggest you taking a look at, because it's a great way for you to structure your test. It will give you a whole sheet where you can actually say, these are the scenarios I'm going to test, and then you can accept them, and if some of them fail, you can give that back to the developers as part of their user story in their Azure DevOps. It's a good way to give tabs on what has been tested successfully and what hasn't been tested successfully. And you can also leave comments on what exactly happened and what did you expect to happen. Now, as a conclusion for this video, software testing is a science in itself. It's a very complicated field, and actually to write software tests is more complicated than writing the software itself in many aspects, because there's so many things that you have to think about. And besides this simple testing that we talked about, you also have something like gray box testing, black box testing, smoke testing. You have integration testing, flow testing, load testing, performance testing, usability testing. The list goes on. I might make a video series at some point about software testing in general, because it is a very interesting area, but it's also something that you cannot just cover in one sitting, and it's something that you have to keep on working on, because it's something that takes some time to learn. But it's a good idea to start thinking about how to implement testing as part of our workflow. And remember, the sooner you catch a bug, the easier it is to fix. Well, that was it for this video. Thank you for watching. Stay safe and goodbye.